Hello coders, welcome back to our channel GDG Triple MUT, and in today's video we are going to discuss Starters 246 Division 4 questions. So the first question is plant. You know that for the ith of the next n days the temperature will be A of I. You have a seed for a tree that needs to grow in 2 days. The height of the tree will be minimum of the temperature on the 2 days of growing, and we need to find the maximum height of that tree. So let's move to the whiteboard and understand what the problem is saying. Suppose we have an array 5, 7, 6 and 8. All we need to do is checking pairs of 2 consecutive days. We need to get the minimum value and maximize that. For 5 and 6, it will be 5, the minimum value. For 7 and 6, it will be 6, and for 6 and 8, it will be 6. So the maximum between 5 and 6, it will be 6, and our answer is 6. That's all. We need to check the consecutive days, get the minimum, and maximize that. Let's see what the code will look like. So here we are taking the inputs and initializing an answer as 0. We will iterate through I equal to 0 to n minus 1, because for n there will be no next day. So we will iterate till n minus 1. So here we are getting the minimum value of 2 consecutive days and maximizing them. That's all with the answer. So here is our next question, red yellow cards. A football player has received a total of R red cards and Y yellow cards. He gets sent off if either he receives a red card or if he receives his second yellow card. So we need to minimize the count of sent offs. So let's move to the whiteboard and understand the rule. So there are only two ways a player can get sent off. First is receiving 2 yellow cards, and second is receiving a red card that will send off the player immediately. So what will be the naive thinking? R plus floor of y dividing by 2, but this will cause us a wrong solution. Why? Let's understand this. Because every send off resets yellow cards. What does that mean? Let's see in this example. Here we have 2 yellow cards and 2 red cards, and we are arranging it like yellow, yellow, red and red. So this is second yellow card that will cause a send off, and red card and red card there will be 2 more send offs. So there will be a total of 3 send offs. But if we arrange them in an alternate manner, like yellow, and red, so there will be no second yellow card. What does that mean? Yellow card, red card, that will cause a send off, and again the first yellow card and red card that will cause a send off. So there is no second yellow card. Let's take one more example. Here we have 3 yellow cards and 2 red cards, and we are again arranging them in an alternate manner. First yellow card, red card, sent off, again the first yellow card, no sent offs. Red card, sent off, and Y, first yellow card, no sent off. So here it is only 2 sent offs instead of 4, right? So what will be the minimum sent off formula? First we will count the yellow sent offs, that will be floor of Y by 2. Then we will calculate the remaining, that will be maximum of 0, floor of Y by 2 minus R, that I have already explained you here. And the overall answer will be R plus the remaining part, because we cannot optimize the count of red cards, right? So let's move to the code editor and understand the code. So here we have yellow pairs, that will be Y by 2, and remaining maximum of 0, yellow pairs minus R, and we will sum it up like R plus remaining, and that will be our answer. So here is the last question, waiting. There are n people waiting to enter a movie theater. However, the movie theater has a weird rule. The people have to enter in an order that they have bought the tickets. The people are indexed 1 through n based on when they bought the tickets. The ith person shows up at the time A of I, but he may have to wait for others till he is allowed to enter the movie theater, assuming we can enter instantly otherwise. So let's move to the whiteboard. Here we have some observation. Suppose we have an array 2, 1, 4 and 3. So the first person arrives at 2 unit of time, second person arrives at 1, third person arrives at 4, and the fourth person arrives at 3. Though the second person arrives the earliest, but he has to wait for this first person, and whenever the first person comes, he can enter. So what will be the entry time for the rest of them? For this, the entry time will be maximum of these two, like 2 and 1, 2. For this, the entry time will be maximum of 1 and 4, 4. And for these, the entry time will be 4 and 3, maximizing 4. So what will be the entry time? Maximum of arrival time and previous entry time. Maximum of arrival time and previous entry time. So If a person arrives at 1 but the previous enters at 2, so the second person has to enter after this. So it will enter at 2. So let's compute the waiting time. If a person is arriving at 3 and entering at 7, what will be the waiting time? 7 minus 3, 4, right? Same goes here. Entry minus arrival, 0. 2 minus 1, 1. 4 minus 4, 0. 4 minus 3, 1. So it will be entry minus arrival, and it will be maximum of arrival time and previous entry time. Let's move to the code. So here we have answer as 0 and entry time as the first person, because whenever he comes, he can enter. So we will iterate through the array. Entry time will be maximum of entry and arrival time. Like entry is the previous entry time and arrival. And answer will be entry minus arrival. We will sum it up and this will be our answer. Thank you.